Hi everyone, welcome to channel Qtomation. In previous sessions, we have seen what are the benefits of creating test automation framework. What is the need of API automation framework? We have also seen there are different phases while creating test automation framework. So we have to go by each phase before creating actual development of framework. From those stages, we have already seen selection of test cases and understanding the requirements. So in our last session, we have selected the API which we want to automate. We have created one Excel sheet, and in that Excel sheet, we have put all those API. For example, if you see, this is the test sheet which we have created in our last session. And these are the sample test cases which we are going to automate by using REST assured API automation framework. So this contains creation of new user, getting that user details using that new user ID, updating updating the user details, deletion of that user, and couple of negative cases as well. So that is the first phase where we have to understand all the APIs, understand all the requirements, manually test all those APIs. That's it. So once you understand all the API requirements, next phase is selecting the right tool or library and designing the framework structure. So, you should not jump directly writing the code for the framework because when you work in different organizations, there are different type of tools, libraries which are available which can perform test automation for APIs. But depending on the application you are working upon, what are the type of APIs? How many APIs are there? How many test environments are there? There are multiple factors which we have to understand and analyze first to select the proper right tool and library for API automation. So for our framework, we are going to use REST assured library, TestNG, and it's going to be a Maven project in which we are going to use different components that I will show you in some time during the designing the framework. So let's understand, for designing the framework, there are multiple ways. There is no fixed approach for any type of framework. There are different type of frameworks which are available, and anyone can customize them depending on the requirements. So whatever application, whatever project you are working on, you have to first understand and then decide what type of framework you are going to develop. So for our tutorial purpose, we are going to automate all those APIs by using hybrid framework. So there are multiple components which are present inside any framework. So I will just go through some of the basic components which are required to create the framework. So the framework which we will create will have some structure like this. And these are the different components, or we can say a different type of files which we have to create in our project. What are those different files? For example, property file, reader file. I will explain on high level what is the purpose of each and every component in this session. But in coming sessions, we will see in detail how we can implement those in our actual framework. But just on high level, let's understand what are the different things which are required to create any framework. So first one is property file. So main purpose of property file is to store base URL, authenticated tokens, environment URLs, and other config variables. So whenever you are going to do API testing, there are multiple type of URLs which we have to handle in our APIs. So we can store all those URLs in property file. That can be a base URL, or it can be a tokens as well. For example, if your API needs some kind of bearer token or any type of token, those authentication tokens also we can store in properties file. Environment URLs, for example, if you are working on staging environment, let's say you are working on dev environment, so there can be different environments on which we have to test those APIs. So all those environment details, endpoints, we can store in this property file. And such similarly, any type of configuration variables also we can store in property file. Property file will allows easy changes to the environment without affecting the code. Without changing the code, we don't have to change endpoints in all the test cases. So they are given in only single file, property file. So if you put all the endpoints in property file, and tomorrow let's say some of the endpoints change, so you don't have to change in all the test cases. You just go to property file and change the URLs. That's it. So it makes changing the details, changing the environment details very easy if you have property file. It also support different profiles. For example, dev profile, QA profile, production profile. So depending on that, we can use property file. That is the high level usage of property file in our test framework. So if you see what is the purpose of property file, it stores base URI, authentication tokens, environment URLs, and other config variables. It allows easy changes to the environment without actually changing the code. So without changing the test cases, you can simply make change in your property file only, and it will reflect in all the other places. So that is the main benefit of using property file. So property file we have to create in our test automation framework. Along with property file, we have to create one base test. What exactly is this base test? So base test is used to initialize common setup like base URI and authentication headers. So we have stored those details in property file, but when actual project execution starts, we have to initialize some of the common setup. Like for if you have written 10 test class files, and for all those files you have to initialize a base URI. So that purpose you can do via base test. It's like a parent of all the test classes. So all the test classes files will be child of this base test. It is used to set up report configuration. For example, extend report. So in our framework, we are going to use extend report. For extend report, sometimes we have to do some customization, some configuration. Those configuration we can do via base test. So once you perform those configuration in the base test, you don't have to add all those configuration in individual test files. So you just write whatever initial configuration you want in each and every test class that you can provide in base test only. And this base test is a parent of all the test cases. So automatically whatever configuration present in base test will be inherited to test cases, because each test case class file will be child of base test. We will use inheritance concept here. So whatever present in base test will be automatically inherited to all the test classes. So that means whatever initial configuration we have to do before executing any test class file, whatever initial configuration we have to perform, that all we can set up in base test. It can also provide setup and tear down method for test. So before executing any test class file, we have to perform certain actions. Those actions we can provide in setup method, and after all the test classes execution is completed, we have to perform some closure activities. All those closure activities we can add in tear down method. So that part also can be handled by base test. We will see practically in our coming sessions as well. So it's okay if you don't understand all these things at this point. We will going to see, we are going to implement all this stuff one by one in our coming sessions. But just on high level, just understand the function of every file. Why we are adding this component in our test automation framework, that we have to understand. Base test also acts as a parent class for all the test classes. So in our framework, we will create base test which will contain initial setup which is required for all the test classes. Actual test cases will be written in different package, and all those test cases will be children of this base test. So base test is a parent class, test cases are its children class. We can say a child class. So whatever present in the base test will be usable in the test cases. For all the test cases, those part will be available. So that is the main purpose of using base test. There is one more component, config reader. What is the purpose of this config reader? Config reader reads the property file values at runtime. So we have seen the property file. Why property file? So we have added different details in property file like base URI, authentication token, etc. But when we execute the test case, that property file data needs to be read. So to read the property file data, we have to write config reader. So it's a class file in which we have to write some certain code which will read the property file values at runtime. It also provides methods to fetch config parameters like URL, token, timeouts, etc. So whatever details we have put in the property file, to read those data, we have to create config reader. It ensures centralized config management. So that is the purpose of config reader. So after config reader, we have some Pojo packages. What is this Pojo packages? So whenever we are doing API testing, we have to pass certain payload during post request or put request. We have to pass the request body. That request body we can create via Pojo. We have already seen this in our previous sessions. Pojo, by using Pojo, we can create the request body or request payload. It contains plain old Java objects. So Pojo classes we have to create in these Pojo packages. It will contain all the Pojos. So all the Pojos will be present in this Pojo package, which will be useful for request and response payloads. It also helps in serializing and deserializing JSON for API requests and responses. It also enhances code readability and reuse. It is useful for request payload because if you write all the request payload in your actual test cases, it will become very lengthy and it will be very difficult to manage as well. But if you put all the request payloads in one dedicated package, it becomes very easy. So that is the main purpose of this Pojos package. It will store all the Pojos which we require for our request payloads. After Pojo, so you have understood property file, config reader, what is this payload Pojos. Then comes this user CRUD service. Now what this file will do? So this is basically one of the Java file which we will create. It will perform all the CRUD operations. So if you see what are the different test cases we have, post, get, put and delete, right? So four type of post, get, put, delete. So four type of operations, four type of request types we have to handle. So we have to call create user, update user, delete user. All those operations will be performed in this user CRUD service.java file. So what this will do, it will contain actual operations, create, update, get and delete. All the different four methods will be present inside this user CRUD service.class. In this Java file, all those four operation methods will be present. All those methods will be execute API request with proper parameters and they will return REST assured responses. So the actual operation where we are going to call the API, right? So we are going to call the create user API. So that actual operation will happen in this specific file where we are going to define, create, update, delete, and edit methods. So all those operations will be performed in this user CRUD service file. It will take the base URI, it will take the request payload, it will call the request, it will fetch, it will return the response. So all those four methods will return some response. So actual operation, actual method which will be called will be present inside this user CRUD service. It basically serves as a service layer abstracting HTTP calls from the test. So when you write the test cases, actual test cases will be written in different folder or different package. In actual test cases, we will perform assertions, but we will get all the responses from this user CRUD service. For example, in the user CRUD service, you will write the method create user, update user, delete user, get user. And those methods we will call in these test cases. So when you are going to write the test case for create user, you don't have to write all the code required to call those API. That operation will be already taken care in this user CRUD service. You just get automatically response in this test cases folder and just call this method from this user CRUD service, pass the details, and you will get the response in return. And then you can perform assertions in the test cases. So actual operation will be performed in this specific service file. So that is the benefit of creating user CRUD service. So in test cases, so it's basically concept of abstraction. How the create API is going to called, what are the different things which need to call the create API, all those things will be taken care in the user CRUD service. In test cases, we just have to implement that. We just have to call those method. So that is the purpose of this user CRUD service .java file. It will perform all the actual API calling operations. All the four methods will be present inside this file. And we just have to call those methods in our test cases. Then there are some files like utility files. So your utilities folder will contain reusable methods. For example, there can be different type of reusable utility classes for logging, test data reading, for data conversion, or any other type of operation which is frequently required in our test cases. So instead of writing repeatable code in each and every test case, we can simply create utility file and we can reuse those utility file in different test cases. For example, to read the Excel sheet, we have to write certain code that will be considered as a one utility file. If you are going to do a data driven testing, we have to read the data from the Excel sheet. That reading of the data is a common utility that can be present in this utilities folder. It can also include some helper methods for date, JSON parsing, or environment handling. So depending on your actual test case and what you want to do, if there are certain actions which are very frequently used in the test cases, we can create and keep that code in this utilities file. So what is the purpose of utils file? It basically contains all the reusable utility classes. It uses reusability for utility classes for logging, test data reading, data conversion, etc. It can contain Excel reader for data driven testing support. It may include helper methods for date, JSON parsing, or environment handling. That is the purpose of utility folder. So we have understood utilities also. What is test data files? It is especially used for data driven testing. Suppose you have one test case. Let's take example of create user. So in create user, if you see the request body, we have to pass details like name, email, gender, and status. So this is for this specific user. What if I have to execute for such 5 different users? So every time do you write all the 5 test cases separately with 5 different type of data? No. We can write the same test and we can take the help of data provider. It will read the data directly from the Excel sheet In Excel sheet, we will put all the 5 users detail. It will pick one by one detail for every user. So the same test will be executed 5 times with different data set. That is called as a data driven testing. So for such testing, we require test data file. That test data file will be present inside this test data files folder. Then comes logging. So whenever we are executing the test cases, we are writing the test cases, we have to log certain things. So logging will help us to troubleshoot any issues, how the test flow goes, how the code execution goes. That we can track by using logs. To generate the logs, we can use log4j2 library that I will show you when we develop the framework, how to implement loggers as well. So by using loggers, we can log all the different type of things whatever we require during the writing the test cases. So that is the benefit of logs. After test execution, we need some visually appealing reports as well. How many test cases passed, how many test cases failed, all those things will be present in the reports. So those reports will be generated inside extend report. So we are going to use extend report, which will generate all those reports. And is most important things again, pom.xml and testng.xml. So what are the purpose of pom.xml file? So pom.xml, it is used to manage project dependencies like rest assured, JSON path, extend reports, log4j, testng. So whatever dependencies, whatever libraries we need in our project, those can be automatically downloaded and implemented in our project by using pom.xml. It's a dependency management library, dependency management file. So in pom.xml, we just have to put the dependency and it will automatically handle and download all those dependencies in our project. For example, we need different type of dependencies like rest assured library for JSON path, extend reports, log4j. So all these libraries, we can put the dependencies in pom.xml file and it will automatically manage those in our project. It can be used to define plugins as well, to build the steps and repositories for the Maven project. So once you develop the Maven project, to execute those Maven project, we require some plugins. All those plugins also we will put in pom.xml file. Testng.xml. Testng.xml is used to define test suites and test to run in batch. So we can group the test cases. At a time, if you want to select specific test cases, we can group those and we can define in that testng.xml file. We can also control order of the test case execution, parameterization of the test execution, parallel execution, and cross browser testing. All those things also handled by testng.xml. So that is the main purpose of pom.xml and testng.xml. We will write the test cases in separate package like create user, update user, etc. So we have seen property file, config reader, user CRUD service, base test cases, payload POJOs, test data files, utilities, logs, reports. And then once you create the project by using all these components, that comes under the development. So this is basically development part. We have to integrate all these components in our framework. And then comes execution part. We can execute those by using testng.xml. After that, reports will be generated. That means your project will locally work fine. Once your project's working fine in your local system, we can push that code to remote repo as well. So once you push the code to your local repository, that is Git repo, and from Git repo, we can push that code to remote repository, that is GitHub repository. And once you push that code to GitHub repo, then you can implement continuous integration as well. So we can execute that test by using Jenkins or GitHub Actions as well. So these are basically CI tools. So we can execute the code by using Jenkins or GitHub Actions. So this is on high level is basically architecture of our framework. We can quickly execute the test cases locally by using Eclipse. Once that is working fine, we can use command line to execute all the test cases outside of the Eclipse to check for CI compatibility, and then we can push the code to GitHub for version control, and then we can integrate that code with Jenkins or other CI tools for scheduled and automated pipeline execution. We can schedule the execution, it will automatically execute our test cases. So that's how high level architecture of our framework which we are going to develop. By using those 6 cases, we will first implement all the components in our framework. In our coming sessions, we will implement all these components one by one, and then we will execute all the test cases on Jenkins as well. That is our end state. So in coming sessions, we will start with development of framework. We will start defining the project structure, folder structure, and we will start adding files one by one for these components. So I hope you like this video. Let's meet in our next session for actual development of the API REST Assured framework. Thanks for watching.